When can we call two triangles similar? Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. In the triangles given here, angle A is equal to angle P. Angle B is equal to angle Q. And angle C is equal to angle R. Moreover, the ratios AB to PQ, AC to PR, and BC to QR are equal. So we can say triangle ABC is similar to triangle PQR, can't we? Now, to find if two triangles are similar, do you think we need to look for all the 6 equality relationships? Not at all. There are simpler ways. We can call two triangles similar if certain minimum conditions are met. This is because the remaining conditions automatically hold true. So what are these criteria by which two triangles can be considered similar? They are the AAA criterion, the SSS criterion, and the SAS criterion. Let's now look at the AAA criterion. The AAA criterion of similarity of two triangles states that in two triangles, if the corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. Let's try to prove this theorem by considering triangles DEF and XYZ, where angle D is equal to angle X, angle E is equal to angle Y, and angle F is equal to angle Z. Now, we need to prove that the ratios DE to XY, DF to XZ, and EF to YZ are equal. How do we go about doing this? Let's use some simple constructions. In triangle XYZ, let's mark XP equal to DE and XR equal to DF. And join points P and R. You're wondering how this is going to help us prove the theorem, aren't you? We'll prove it in 2 steps. First, we'll show that PR is parallel to YZ. Next, we'll use the basic proportionality theorem and some calculations to prove that the corresponding sides of triangles DEF and XYZ are proportional. Shall we start now? The first step is really simple. We can see that triangle DEF is congruent to triangle XPR by the SAS congruence rule. So angle E is equal to angle P. And we already know that angle E is equal to angle Y. Based on this, we can now say that angle P is equal to angle Y. What does this imply? You're right. Segment PR is parallel to side YZ. So we're through with the first step. Now, let's move to the second step in the proof. By the basic proportionality theorem, we can say that the ratio of XP to PY is equal to the ratio of XR to RZ. Next, let's try changing both sides of the equation to their reciprocals. Now, let's add 1 to both sides of the equation Looking at the figure and the equation, what can we say now? xy upon xp is equal to xz upon xr. Let's change both sides of the equation to their reciprocals again. From equations 1 and 2, we can say that the ratio of dE to xy is equal to the ratio of dF to xz. Similarly, we can prove that the ratio of dE to xy is equal to the ratio of EF to YZ. Now, what can we say about the corresponding sides of triangles DEF and XYZ? They are in the same ratio, and so the two triangles are similar. Yoo-hoo! We've just proved the AAA criterion of similarity. From the AAA similarity criterion, we can also say that two triangles are similar if just two angles of one triangle are respectively equal to two angles of the other triangle. Can you guess why? This is because the third angles of the two triangles will automatically be equal due to the angle sum property of a triangle. We call this the AA criterion of similarity of triangles.